Good afternoon. This work is dedicated to the development of a fracture model for an elastic-brittle solid with statistically distributed strength characteristics of subregions and the application of this model to describe fracture processes of bodies with stress concentrators under biaxial loading. The methodology of fracture processes numerical modeling is approved to take into account the partial loss of load-bearing capacity and the appearance of local anisotropy. After the fracture criterion in the subregion is implemented, the intact anisotropic material is replaced by an orthotropic one, the anisotropy axes of which are oriented in accordance with the directions of the principal stresses at the moment of damage, so the propagation of the correct through the subregion is simulated. Elastic properties of the orthotropic material ensure absence of resistance during the deformation across the simulated correct, but show resistance during the deformation along it. If the fracture criterion is implemented again, the subregion is considered as completely fractured. To study the feasibility of modeling the processes of destruction of elastic brittle bodies within the framework of the developed methodology, the problem of biaxial kinematic loading of a plate with stress concentrator is considered. The results demonstrate that the orientation of the anisotropy axis corresponds to the direction of macrodefect's growth from the stress concentrator. The comparison of the results obtained by using the improved methodology and the previous one shows the expediency of partial bearing capacity loss taken into account. Influence of loading mode and variation coefficient of strength properties on the loading diagrams, damage evolution kinetics and strength of the plate with the stress concentrator is considered. The applicability of the previously developed approach to assessing the type of damage accumulation based on the analysis of numerical solutions of boundary value problems of elasticity theory is evaluated. The feasibility of using this approach for various laws of distribution of strength properties and loading modes is demonstrated.